Eclipsing 22,500 megawatts, the colossal structure disrupted Earth's rotation. Towering at 185 meters and stretching 2.3 kilometers, it commands the Yangtze River. The dam's reservoir holds 39.3 billion cubic meters of water, equivalent to 16 million Olympic-sized pools, reflecting audacious human endeavor unparalleled in scale. Construction on the Yangtze River took 17 years. Engineers overcame geological challenges to build the world's largest power station. Critics doubted the project's feasibility, yet its vision rooted in controlling flooding transformed skeptics. With a height of 181 meters and spanning 2.3 kilometers, the dam is a testament to human ambition and engineering marvel. In 1931, the devastating Yangtze River floods killed 3 million, underlining China's urgent need for flood control. The Three Gorges Dam was envisioned to mitigate such catastrophes while fostering economic growth through hydroelectric power. Yet the sacrifices included displaced communities. 1992 marked the official approval, but what deeper need did it unveil? One that still haunts its legacy. The Three Gorges Dam stretches 2,335 meters long and stands 185 meters tall. It contains 27.2 million cubic meters of concrete, enough to build 63 Hoover dams, and 463,000 metric tons of steel, which could wrap the Earth 4 times. 35,000 workers dedicated more than a decade to complete this colossal structure. Yet with such mammoth ambition comes an equally immense responsibility to nature. In 1993, engineers faced the monumental task of taming the Yangtze River. Diverting its colossal flow required unprecedented ingenuity. The core challenge, navigating a 185-meter-deep U-shaped gorge. They employed concrete cofferdams and sluice gates, redirecting water with precision. A staggeringly complex feat of hydrodynamics and structural engineering. The impossibility loomed. So how did engineers turn the impossible into the possible, confronting the untamable rift? The secondary challenge was reducing cavitation in the turbines. Cavitation had the potential to erode metal unexpectedly. Engineers developed a special hydrophobic coating to counteract these forces. This coating, applied to the Francis turbines, transformed their resistance to the abrasive effects of rapidly moving water, tackling the crux of the problem. Such innovation ensured operational integrity while controlling unforeseen failures. The construction of the Three Gorges Dam began on December 14, 1994. Site preparation demanded the removal of 102.6 million cubic meters of earth, an endeavor requiring a massive workforce and machinery fleet. An early challenge was diverting the Yangtze River. This obstacle was overcome by temporarily constructing a cofferdam, allowing excavation to proceed unhindered. In 1997, engineers uncovered geological faults. These faults were perilously close to the project site, threatening the dam's future stability. Engineers, led by Huang Wanli, faced a choice: abandon or innovate. They pioneered anchoring techniques, drilling arrays of grouted bolts to secure compromised rock masses. But questions remained. Could this unforeseen geological glitch really unravel years of meticulous planning and relentless toil? 40,000 workers, including engineers from Sinomarch and West China Group, labored in shifts day and night, enduring the relentless heat of Hubei. Lu Zhang, a welder, left his home village for 5 years. He toiled under sweltering conditions, forging the dam's steel skeleton, bound by determination and a promise of progress. Their diverse hands built history. Supplies conjured the colossal. The dam used 27.2 million cubic meters of concrete, shaping the monolith. Steel shipments totaling 463,000 metric tons journeyed across China. Innovations emerged: custom steel alloys for durable turbine shafts and kilometers of high-tensile cable for structural integrity. Each component meticulously sourced, transported, and installed at Yichang, realizing a once impossible vision. Pioneering technologies emerged at the Three Gorges Dam. Engineers developed the massive ship lift capable of elevating vessels up to 113 meters, setting a world record. Custom machinery like powerful turbines and advanced floodgate mechanisms were built. Insights gained here influenced global engineering. Dynamic simulation software optimized water flow, balancing power generation with environmental impact. In 1998, unexpectedly unstable geological strata nearly derailed the Three Gorges Dam project. Hidden fault lines beneath the Yangtze River's bed posed a seismic risk, discovered by engineers during deep drilling operations. Emergency geological surveys were immediately launched. Strategically, engineers reinforced the dam's structure with additional steel bracing. However, questions remain about the dam's ability to endure future seismic forces. As tension builds, will the dam withstand nature's formidable stress test? Temperature fluctuates between cool and damp. Whirring machines echo through enormous chambers. The soundscape hums with technology. Control rooms equipped with advanced computers monitor 32 generators ceaselessly. Vast tunnels stretch over 600 kilometers, linking machinery rooms to other internal networks. Maintenance workers traverse these intricate labyrinths daily, ensuring each segment aligns perfectly. Their vigilance secures the dam's integrity and safety under constant scrutiny. Rising waters of the Three Gorges submerged 13 cities, 140 towns, and 1,350 villages. Ecosystem impacts were profound. Spawning grounds for the endangered Chinese sturgeon vanished. Over 1.2 million people relocated by 2008. Authorities conducted limited biodiversity surveys and established conservation zones, yet ecological losses continue to spark global debate. Budgeted at $8 billion in 1994, the Three Gorges Dam's final cost exploded to over $31 billion. This surge involved global investors and the China Yangtze Power Corporation. The dam employed thousands, boosting local GDP while facilitating increased trade. Despite economic gains, financial miscalculations raised doubts about the project's fiscal wisdom. The Three Gorges Dam transformed China's power landscape. It generates 84.7 billion kilowatt-hours annually, providing clean energy to megacities like Shanghai and Chongqing. Before its inception, many rural areas lacked consistent electricity. Now the dam supports nearly 10% of China's hydroelectric capacity. Shipping traffic on the Yangtze River increased fivefold, boosting trade through Yichang and beyond. The Three Gorges Dam, completed in 2012, remains the world's largest hydropower station, generating 22,500 megawatts. This colossal structure inspired the Belo Monte Dam in Brazil. Engineers from HydroChina collaborated globally, transferring knowledge. Completed in 1997, the dam wall stands 185 meters high, an engineering marvel that catalyzed further hydropower development across continents, exemplifying human ingenuity and ambition. China envisions even grander projects. Discussions hint at hydropower advancements on the Yarlung-Tsangpo River, aiming to exceed 5,000 meters. Debates grow over sustainability and geopolitical tensions. The question persists, will these ventures dwarf the Three Gorges Dam by 2040? It's ambitious, confronting natural and political hurdles that defy immediate answers. A lone figure stands at twilight, silhouetted against the dam's imposing wall of concrete, 185 meters high. The 2.3-kilometer expanse embodies humanity's relentless struggle to master the untamable Yangtze River. A testament to engineering ambition, it questions the limits of human persistence. You've journeyed through the monumental scale of the Three Gorges Dam. Witness its intricate machinery and relentless power. Discover more engineering marvels on our channel.